Hey guys, so we just were working on this problem a few minutes ago when I was having technical difficulties, so I just wanted to upload it real fast in a quick form. So we had an ellipsoid that we graphed, and it was given as x squared divided by 4 plus y squared plus z squared is equal to 1. And in class we saw that we picked a point. For us it was C, and that point was at x equals 1, y equals 0, z equals root 3 over 2. And we wanted to know the tangent plane at this point. We saw in our time together that if I were to graph it this way and wanted to find the slope when y is held constant, I ended up getting dz dx was equal to, I believe, negative x over, actually I have it, I think, on the last page. We can just go look over there real fast. It was negative x over, here we go. Great, over 4 root 1 minus x squared over 4. Now that was a bit more complicated than we cared for because we just wanted to know the slope when x is equal to 1. And so that whole thing simplified down to negative 1 divided by 2/3. So for us, when we're considering it at the point, so often use a symbol at the point, x equals 1, say, then we had negative 1 over 2 root 3. So that was helpful because it told us that this vector right here had a slope, I'll call it u, had a slope of, well, when z changes negative 1, x changes 2 root 3, right? So rise over run. So 2 root 3, 0, and say negative 1, right? And then we also took a front shot of this, which gave us a curve, and it gave us 0, 1, 0 for the tangent this way. So if you hold, so x coming right at us, the y going to the right, z going up, x and z were not affected, and we just had a y of 1. So my other tangent vector here, maybe I should do it in green, say, was v, which gives me 0, 1, 0. Great. So we were going to take those two vectors, u and v, and we could take a cross product of them if we want to find an orthogonal vector. The reason for that is so that we can get the plane. So you could take the cross product of those two, and you know how to do that. It's also good enough to say if I can find some w that's orthogonal to both of these. So if I do the dot product of w with u, I'll get a 0, and the dot product of w with v, I would get a 0. Then that will be enough. So that's actually a little bit quicker for me. Since I don't care about the size of the cross product, that will be enough. Because notice, w, if I just say it's ABC, w dot v just gives me b, and that has to be 0. So b is 0. And then w dot u gives me, so 2 root 3 times a. Oops, it's no longer a vector. Let me erase that a little bit. 2 root 3 times a plus, or minus, in fact, minus c. So for these, since I don't really care about the size of w, I'm just going to say a is equal to 1, and then c would be equal to 2 root 3, and that will give me a 0. So my orthogonal vector is 1, typo, 1, 0, 2, root 3. Great, so then I can write the equation of my plane because it goes through point C, it has that direction. So with those two pieces of information, I can say my plane is x minus 1 plus 2 root 3 times z minus root 3 over 2. And if I stick that in over here, when I wrote it on this other screen, let me pull it over now. I in fact used something else slightly different. I used 1/2 instead of 1. So let me change that, and root 3 instead of 2 root 3. 2 root 3. So that's, if I write that in, it does give me that tangent plane all nice and pretty. And that's what I was having such a hard time getting GeoGebra to do for me before. I guess it's just nice to delete a lot of equations. So if you're doing stuff with GeoGebra, I would say be careful. What's annoying is it often doesn't let you, if you start typing something but it's not perfect, it'll just erase it. That's one thing. It often doesn't let you, sometimes I'll try to rearrange the equation so I can see them better. It won't let me do that unless I'm very careful. And then if you just like backspace everything out of there to delete something, it won't go away. So you have to actually go in here and hit delete. And those things I was forgetting to do, so that's why it got so strange. And so that method is how we did it together. You know, as a pro tip, that concept that we were talking about of how to get this faster, I actually give you a preview of that, because that's how I do it. So if you know the trick, you can actually go from this equation to this one very, very quickly. And when I do go to this sort of new equation here with this quick method, that's when you end up with the 1/2 and the root 3, which is why I had those when I first wrote it up. So notice these two though are equivalent because one's just twice the other one. And there's a 0 on the right hand side, so it's not a big deal. So here's the trick. Y'all ready for this? This is actually a little bit of a jump ahead, but I'll preview it here. We're not going to do it a lot. So with that equation, x squared over 4 plus y squared plus z squared is equal to 0. And we had the point 1, 0, root 3 over 2. Let's take this whole equation, and we're working under this idea of, well, let's think, how does x change? Can I hold these two constant? If I held those constant and took a derivative of this left-hand side, well, that would give me 2x over 4, right? Because if these are constants, they go to 0 when you take a derivative of them. So we're at the point, though, at C, so that this gives us a slope of 2/4 or 1/2 for my x. Likewise, oops, I'm getting a little bit out of the screen here. Likewise, if I want to think about the direction of y, how does y change at this point? You know, hold everything else constant, I'll get 2y. At C, well, that's 0, right? And then for z, if we hold everything else constant, we get 2z. But at that point C, this gives us a value of root 3. Why is that helpful? Well, these give me this, well, that's my orthogonal vector. Right? So my tangent plane is 1/2 x minus the x coordinate plus 0, so we forget about that, plus square root of 3 z minus its z coordinate. And all that needs to be equal to 0. So that's a quicker way than the way that we did finding the traces, but they're equivalent, and that's sort of the big to do. That's why I had you work through all of that in class to sort of show you there is a long way of doing it, and then there's a shortcut way. All right. Hopefully this is helpful.